as I mentioned, motion in X and motion in Y are independent things. So one way to think of it is, if I move back and forth this way, that doesn't change my distance this way. So motion in each direction is independent. These directions are what we call orthogonal to each other, or normal to each other, which another way to say orthogonal. We choose these three independent directions for a reason, because we can write equations of motion in each direction and figure out which something is at any one time without having to worry too much about how these couple, right? You know, let's look at it, right? There are different ways you could think about it. You could do it, and you could solve where something went using graphical methods. You could look at your vectors for displacement using graphical methods. These we can do in lab, and we'll do some lab stuff where we do this. You'll have to draw some vectors and play around with those. But normally, we're going to be using Excel. We're going to be calculating how vectors add. We're not going to be doing it with graphs, right? So, a few things about vectors. It doesn't matter which way you add them, right? A plus B is the same as B plus A. And you can see our little notation for a vector. Our vectors have this little arrow over the top to indicate they're a vector. A minus A is 0, okay. And these vectors can be written as the sum of their components. And so when you're adding, you've got A is AX I hat plus AY J hat plus AZ K hat, and you've got B AX, well, BX I hat plus BY J hat plus BZ K hat. And you want to add A plus B. Well, these are vectors. X has nothing to do with Y, has nothing to do with Z. And so you have to add just the X pieces, AX plus BX I hat. Don't mix and match, all right? AY plus BY J hat, AZ plus BZ K hat. Not very clear there on the end. So the X pieces add, the Y pieces add, the Z pieces add, and you're left with an X piece, a Y piece, and a Z piece. If you had, let's give a simple example, 5 I hat and B is 6 J hat, what would you do? Well, this is an X piece, that's a Y piece. They don't add to each other directly, and so the sum is 5 I hat plus 6 J hat. It's pretty straightforward. Let me make all this go away. Okay, next slide. All right, this is just what I said before, what I said in the last slide, right? The pieces, the X pieces add, the Y pieces add. You don't mix and match. This isn't, you know, they're apples and oranges. No matter how far I go in X, that doesn't change how far I am in Y. No matter how far I go in Y, that doesn't change my X position. So you can't mix and match. And we'll make sure we do this right in Excel. We're adding vectors correctly in Excel, where you calculate the X component, the Y component, and later on in the semester, the Z component, and you add the X's, and you add the Y's, and you add the Z's.